Hello everyone and welcome back to our series on mastering software design. Today we are diving into one of the fundamental concepts that every developer should be familiar with, the solid principles. Whether you are a seasoned programmer or just starting out, understanding these principles can significantly improve the quality of your code and make your software more maintainable and robust. So what exactly are the solid principles? Well, SOLID is an acronym coined by Robert C. Martin, also known as Uncle Bob, to represent five key principles of object-oriented design. These principles act as guidelines for writing clean, modular, and flexible code. Let's break them down one by one and see some examples. So the first principle is the single responsibility principle or SRP. It states that a class should have only one reason to change. In other words, a class should have only one responsibility or job. By adhering to this principle, we ensure that each class is focused, cohesive, and easier to understand. So let's start by an example. I have set up an console app here with the default message hello world and program.cs. So let's try to make a logger utility to log some messages as we do in our software development practices that we log messages. Let's call it a log entry. So log entry is a class which is responsible for creating log entries. So let's make it public and let me create a list of string to store log entries. And let's create a method to log an entry. So this will store log entries. This will add log entry in the list. Also, we want to output this these log entries in a text file. So save logs and we give it a file name, and here we'll say file dot write all text and write in this file name and convert all the entries to string. And to provide that to string implementation, we override existing to string method. So in program.cs, let's use that logger. We log application is starting. And then let's log application is stopping. Two very simple logs. Let's save those logs in the text file. So logger.save logs, and we give file name logs.txt. Logs saved successfully. Okay, let's run this application. So we see the message log saved successfully, and if we go to show all files and in bin directory, you can see the logs.txt with these specific messages. So this is log entry class, which is responsible for storing those logs in memory and then saving those logs in a text file. But we can already see that it has lots of responsibilities. Now, for example, if I want to log the time here along with these log messages, I have to modify this, and I have to add some more properties here. For example, I can add a datetime field with date and time for the log, and also for the log message. Let me create the log message property here too. These are two properties. Now, in order to save the log entry, I have to so let's log these entries. So to log an entry, we now have to create the log entry object. So variable log entry equal to new log entry, and let's initialize it. So for datetime for log, we use datetime.now, and for log message, use this log entry. Now we can say it a log message, or we can just say it a log. So we are logging this log entry now. Now whenever we try to save it in text file, we also want to output the time for the log. So for that, let's create here uh, let's create here another function string logs, and here we will, but to convert a value to string, we are using toString method here, but to convert it into a string, we will use string interpretation. So we will use log, and here we will use log message. Now to save logs, we will just use this logs method. Okay, let's run this application again. So logs are saved successfully, and if we go to logs.txt, we can see now we are also logging time. Now, if you see the log entry class, you can see that it is already, we are violating single responsibility principle, and this log entry class has a lot of responsibilities. We are not only using its properties, we are also using it to save logs and using it to create logs. So, but the single responsibility states that a class should have only one responsibility or one job. So to fix this, we have to create some more classes. For example, let's add another item here, and let's call that item logs manager. So using this log manager, we can delegate these responsibilities to logs manager. So, let's move this to, so logs manager, say logs, and log entry will represent a log. So if we need to add more properties, we will add more properties here. And if we need to implement the save logic or new line logic, we should change that in logs manager. So each class has its own responsibility. So now let's use logs manager, and everything should work fine. Let's see logs.txt. So we see our logs are there. This is how we use single responsibility principle and give each class single responsibility. Okay, and next up we have the open close principle or OCP. This principle emphasizes that software entities should be open for extension but closed for modification. Instead of directly modifying existing code, we should be able to extend its behavior through inheritance or composition. This promotes code reuse and minimizes the risk of introducing bugs. So, okay, to save time, I have speed up the recordings. Now you can see that I have refactored the code and extracted base logs manager, and it is an abstract class. Now this class is in accordance with open close principle because it is open for extension but is closed for modification. Now for each implementation of files log manager, for if we want to implement a console log manager, we will just inherit it from base logs manager. Similarly, as here we are implementing its abstract function. So this is how we follow open close principle. Okay, next is our Liskov substitution principle, or LSP. This principle states that objects of a superclass should be replaceable with objects of its subclass without affecting the correctness of the program. In simpler terms, it ensures that subclasses can be used interchangeably with their base class without causing unexpected behavior. And in other words, we can say that all the base class methods should be applicable for child classes. And let's understand it with the example we are following. So here we are creating a console log manager and assigning it to base log manager, and when we run the application, we get output on console. But as I change it back to file log manager and feed it the file name and run it, you can see that it executes correctly and we get our output. So in this way, so we can replace base class objects uh, with child class without affecting the behavior of the program. Next is interface segregation principle or ISP. This principle advocates for designing fine-grained interfaces that are specific to the needs of clients. Instead of one large interface catering to multiple clients, we should create smaller, more focused interfaces. This prevents clients from depending on interfaces they don't use, leading to cleaner and more modular code. So clients should not be forced to implement interfaces they don't use. So as an example, you can see that I have separated this print log interface and so that it can only be used by logs printer class. And shared logs class should only use ilog share interface and implement its methods. While logs printer class should uh, implement print logs methods. So we separated both these interfaces and using this print logs method in ilog share interface will violate the interface segregation principle. And last but not least, we have the dependency inversion principle or DIP. This principle promotes loose coupling between modules by introducing abstractions. High-level modules should not depend on low-level modules directly. Instead, both should depend on abstractions. By coupling, uh, by decoupling modules in this way, we make our code more flexible, testable, and easier to maintain. So high-level modules should not depend on low-level modules. Instead, they should depend on abstractions. And here in our example, We are already following dependency invasion principle. So if I go to base logs manager, you can see that base log manager depends upon append logs abstract function, and it does not care about its low level implementation, how child classes implements append log function. So child classes can output to console using a pattern function or output to a text file using a pattern function. So fulfilling the requirement for dependency inversion principle. So thank you for watching this series. Please like and subscribe so that I can share more helpful videos. Thank you very much.